Hey guys, this is another programming stream, and today I'm going to be porting StackVM to CPM. And remember, CPM is I'm going to be running CPM on my Z180 Z180 machine. This will be compiled in Aztec C. I could program it and then compile it in something like High-Tech C, but we'll be doing Aztec C, so it'll be compiled for the 8080. And let me get that situated. I got to there. Now I switched over to the CPM machine so I can see it too. Turn that on. Boot the machine. There we go. Okay. Boot to ZPM. Jade, what's in the last? Core.h. Just trying to see what I have here. I think I can get rid of everything. Cool, blank. Now I can do here, save file. Let's do main.c, new, save as stackvm.c, new, stackvm.h. New, save opcodes.h. So those will be the 4 files we need. Hello. Here, I'll leave my phone out here. Anyway, let me see. What should we do here first? I have my notes. Let's do stackvm.h first. Cool, so dte stackvm.h. Start some if-defs, if-def, f and def, stackvm.h, define stackvm.h, and if. Okay, it's saved. Okay, you gotta define the memory map. So we're going to define stack size. Define stack size equals, let's say, 64. Define program size. Let's say 256. And then define heap size as 256, and then type def. It's type def, so int i16. We're doing we're doing int because the CPM, well, Aztec C, the God. Oh my gosh, hard to keep a straight face here. 6 inches. Anyway, you have to find the size of our i16s, and CPM Aztec C has an int size of 16 bits because remember, HL is a double byte word, and that's the largest contiguous integer size that it can hold. Then we'll do define. No, we'll do that. We'll do that up here. So all the defines are next to each other. Define type mask. So the type mask is gonna be 0xC000. If you watch my other stream, this sort of explain what this is. It's basically it gets the type of the N16. It's the first 2 bits. Define data mask. This will get the data 3FFF, 3XFFF, 0x3FFF. There we go. And then precision. Define precision should be 16 because that's how many bits wide you're going to be doing. Okay, here. Okay. Now, type def struct. We are going to do, this struct is going to be called StackVM, right? And then we need to do program counter. We need to do stack pointer. We need to do a pointer to memory. Ori. Then we need to do, you know what? Let's do it like this. Type 16 that 16 running there, just so it like lines up a little better. Program counter, stack pointer, type data, is it running, and then a memory pointer. And then down here we do our prototypes. So let's do StackVM.c. There we go. So I16 get type I16 get data I16 do permit void void permit void init VM void load program void fetch void decode void execute void run about right. Then let us work on StackVM.c. StackVM.c. One second. Messaging. Okay, right. Include StackVM.h, and then we'll also include opcodes. Include opcodes.h. We haven't done that one yet, but we will. Void init VM. Like VM, because we gotta pass in structs through references. That's the only way to pass in structs on machines like this, because it would make no sense to put the entire struct on the stack. Yes, you are. You are. Let's see. StackVM loc VM. Right. Okay. So now we have to initialize everything. So loc VM PC equals stack size that we defined earlier. Loc VM stack pointer equals 0. We're going to say stack starts at 0. Program counter starts, well, elsewhere, right? Then loc VM type equals 0. Loc VM dat equals 0. Loc VM running equals 0. Loc VM memory equals, and this is the whole thing, I16 colloc program size plus stack size, because basically why have two arrays? Why have two arrays when you can just have it all together? And then size of I16. Cool. Make your code look pretty. Oh, I think we should set running to 1. Okay. So after you initialize, let's do get type. I16 get type instruct, and this will be I16 instruct. It's a return type, because I16 type equals type mask. This is what's in the type register. Type equals type and instruct. You're getting the mask. Shifting over to by your precision. -2. Yeah. Beautiful. Anyway, right. Let's see. I16 get data. Instruct. I16 struct. And we'll do this function. Literally the same thing. Yeah, let's look at a way to copy and paste this. Sorry, I was just getting looking some stuff up that I'll need to use later tonight. Anyway, let's see. How do I select block unset, block end, block start, KB, KK, KB, KK. So let's try this. KB, KK. No. How did I do this? I did KB, KK. There we go. And then copy is Control O, and paste is Control W. Control O, Control W. Hey, there, we figured it out. And then instead of type, it's data. And I think it's the same thing, except I don't shift anything. Looks a bit right. Okay, what? Why did I? Huh, that's weird. I don't know why it copied a tab. Anyway, so after get data, we do void load program, and then this takes two parameters, takes program, and it takes your local VM, which of course we'll make in the main. We don't have immediately. So I16 is a pointer to a memory address program, and then StackVM is obviously a StackVM. It's a pointer to your local VM that you passed in. And then your function. It's pretty spicy, if you know what I mean. Anyway, so let's make our counter I, and then for, hey, this is just like Python, except it's in C. So instead of for range, it is a regular for loop. For I equals 0. I should probably do a decrementing loop, but whatever. I do it while I is less than program size. I++, and then do your code. Look, VM, memory, right? We have to do references. Look, VM, PC plus 1, program counter plus 1 equals program at I. So you have two arrays, right? You're copying the prog array to the look VM memory array by reference. So what's that I is being pointed to I. Oh, that's not 1. That, my dear friends, is I. And then I think, yeah, that's it. Void fetch log VM, right? Same thing. Stack VM log VM. Okay, and basically all this has to do is just increment the program counter. You're getting the next instruction, so just this log VM program counter plus plus, right? Increment by 1. That's all you're doing. Writing some 602 assembly would be very intriguing. And then void decode log VM stack VM log VM. As you can tell, this is why C++ would be a great thing, because these functions would just be attached to the object instead of having to manually do it. Log VM type register equals get type, right? And then look, actually, you know what? We're gonna do this. Get type log VM memory at stack pointer log VM program counter. Sorry. So Control B, Control K, Control O, Control W to paste. Cool. And then that looks good. Save frequently, because remember, this is a system where you can't really just recover stuff. As you can tell, it's on my mind right now. Let's see, void decode, void execute. Look VM, stack VM, look VM. Yeah, I'm gonna try to, in the do permit function, I'm gonna try to do a branch table instead of this case, because that would be really cool. I'd probably be able to do it. I'm not quite sure. We could give it a shot if you want to debug that with me. Be really interesting. Be a new skill. Anyway, execute if log VM type equals 0 or log VM type equals 2. Basically, if the type is 0 or 2, which would be the positive or negative number, well, then just add it to push it to stack. That's all you gotta do. Log VM stack pointer plus plus, and then push the stack. Increment stack pointer, push the stack. Log VM memory log VM stack pointer equals log VM dat, right? What's in the data? Else, if it's not a number, then it's an instruction. So do permit, right? Log VM do primit. StackVM loc VM. Do I want to do a branch table? Okay. You know what? Let's learn together. So how do I do this? This is branch Facebook branch table in C. Okay, so basically it looks like there's typedef void handler. Handler is the name of the function that, well, it's not a handler, it's just the typedef void. Pointer to pointer of type void. And that's exactly what this is. And then each function does that. So let's do this. Let me take a picture of this. There looks like there's one on PLI. That'd be really fun. I don't know how to program in PLI. That's something I wanna do. That is very native to the to CPM. Okay, let's. Pictures look good. Yeah, let's try this out. Let's try this out. So, what was it? Control-Shift B. Cool. You can see this. I can't see this because I'm going right over to the this screen. Okay, so basically I have to go up here, typedef void, what should I call this? Not execute because that's already execute. Instruction. Let's see, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I don't think I could do that. Nope. Sorry, I just hit the arrow key. Let me think of a name. Don't mind the noise. It's. I'm gonna be moving out at some point. Parents are freaking loud. Holy shit. Oh my god, you can hear them. I think my younger sister's home. See, this is why I don't do live videos normally, because I have to deal with this bullshit. Anyway, it's loud, right? It's pretty loud. And then if I'm recording, I have to like stop, wait, and then wait for the stopping to stop long enough for me to get a line out, so then I can just cut out the dead space. Ugh, it's such a pain. Anyway, what's the name for this instruction? let's just call it branch. Branch table. We call it branch table of type void. Okay. So then, how this works is I say how does this work? Call appropriate function. Handler is jump table. Jump table here is an array that is of type def handler, which is of type handler, which is of def void pointer. Gotcha. Okay. So instruct 1, 2, 3, 4, 5, 6, 7. Inster TV 1. Jesus. 1, 2, 3, 4, 5, 6, 7, 8. Look, VM dat. Cool. So this jumps to an array of functions. And I think that's it. Cool. Then void run. Look VM. StackVM. Look VM. Okay. So this is what happens when we run the virtual machine. First, set the program counter to -1 because starting at 0, right? So it has to start at 0. And every time you fetch, it adds 1. And the loop will be fetch, decode, execute, fetch, decode, execute, fetch, decode, execute. So if you start at 0, it'll skip the first instruction. So if you start at -1, you won't skip the first instruction. Look VM PC minus equals 1 while it's running. Look VM running while it's running. Fetch. Look VM, gotta pass it in. Decode. Look VM, gotta pass it in. Execute. Look VM. And then basically after I've done a single instruction, I want to print the top of stack. Printf TOS. D. Look VM. Memory. Hey, look VM. Stack pointer. Cool. Instruction table. And if let's delete this. How do I delete line? Control KY. Nah. let's see. What should we save this as? Okay. Inst.h. Let's just call it that. If in def inst h, find inst h, and if type def void insert table 1, 2, 3, 4, 5, 6, 7, 8 void and then instruction table open StackVM.h open StackVM.c. What do we call it? Instruction table. We gotta call it something. I forget what we called it. Just B table. B table. Ins GB 1, 2, 3, 4, 5, 6, 7, 8. And then basically this is where you put a bunch of your functions. So I have to put the functions here because if I don't put them before it, it will totally ruin it. They won't know what's going on. So let's see, how many functions do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Add, subtract, increment, decrement, up, down, branch, no up. Yes. 8. Add, sub, inc, dec, add, sub, inc, dec. Increment stack pointer, decrement stack pointer, branch if 0, no op. Cool. And then, oh, I didn't save it. So then, of course, what the hell? Wait a minute. Can I do this? Void, but it won't pass in void. Can I do that? Maybe? I don't know. We're going to have to find out. So this will be... void add look VM stack VM look VM. Can this work? Okay, let's try it out. Let's see. Printf add dn look VM memory look VM sp -1 look VM VM Let's see here. And then this is local VM memory local VM sp -1 equals log VM memory log VM sp -1 plus log VM memory log VM sp. And then decrement log VM. Cool. K B K K K O K W. Cool. And then I can just change this sub okay, that works. Jesus. Void. I think this also gets rid of the whole opcodes thing, I think. The need for opcodes as a include file. This one's easy, right? POTUS inc, and this just increments the stack pointer. Or this increments what's at memory. Yep, and then that's Control B, Control K, Control O, Control W. And then increment stack pointer. So actually Control W. So let's change this. ISP, SP, and then instead of this, we just increment stack pointer. And this is the same thing, only you decrement. Okay. Let's do a no-op. Yeah, let's do no-op. Oh, that's right. I gotta rearrange the things in the table. Well, let's do BZ void BZ loc VM stack VM loc VM. Okay, now no op and halt. Or no op, right? Void no op. No op should just be break, yeah. POTUS no op. Okay. Void. Add, subtract, increment, decrement, increment. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stack VM. And halt should just be setting it to 0. Yeah. Jesus. VM. I think that's right. Just looking over here. And then here it's halt. StackVM.c. Okay. So let us StackVM.c opcodes. I think I don't need anymore. No, I will. Let's go to main. See if we can wrap this up here. Include StackVM.h. Include opcodes.h. Let's see here. Int main. What is this? Int argc char argv. Return 0. Okay. Oh, while we're at it. Nah. I16i. I16 copy size. We're going to set up some predetermined stuff and then initialize it. StackVM. StackVM. So now we have created a new virtual machine. I16 data equals, and this will be the program 3 for add halt. Let's do that, right? Cool. So that should be the program 3 for add halt. And then let's do the program. This will be copied over. This is what the what the function load program does. Copies this program into memory. size 16. I just did this a little nicer. Colic. Prog size of I16. Copy size equals size of data, right? Divided by size of I16, right? Remember size of is a type. And then for I equals 0, I less than copy size I plus plus. Program I equals data I. Wait, what? Damn. Besides, right. Okay, now let's start the virtual machine. VM StackVM. Let's put some code up here. I'll put some words up here. StackVM 0.1. Printf stack allocated D stack S printf prog allocated prog S then printf heap allocated D heap size put S load program and then StackVM run StackVM and then free everything. Free StackVM.memory, free that pointer, and then free program. Okay, and I think that's all left is just the opcodes. Almost done here. And def opcodes H define opcodes H. We're gonna find out exactly how it breaks. And then define halt 0, 0, define add 0x1, define subtract 0x2, define increase 0x3, define deck 0x4, define ISP 0x5, define DSP 0x6, define BZ 0xe, because I haven't quite figured this out yet, define NOP 0xf. Okay, let's try it. So fcz StackVM dot why is this not working? Error 7. Let's dt StackVM.c. Oh, there we go. fcz StackVM. StackVM.h. StackVM.c. I don't know why I added that. StackVM.h. Jeez. There we go. fcz StackVM. dir dt ins.h. Nine. Let's compare. StackVM. Line 72. DTE StackVM.c. Line 72. Strict table. VM. Oh, DTE StackVM.c. FCZ StackVM. Error 34. Let's look that up. 34 and 69. Nah, 69. Okay. Oh, sorry. There we go. 34. Undefined symbol. Only reserve words and names which have previously defined. This error is often resolved typographical error or omitted declaration. And 69 is missing semicolon. Okay. Let's look at this again. Instruction table. PE H. And STR 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. Why does it say TE StackVM.c? Oh, Jesus! I'm stupid. I can't believe that. So close. TE StackVM.c. If I don't finish this here, like soon, I'm just gonna head to bed. And pick it up later. Error in argument declaration. Error in argument declaration. Declaration lists form of parameters. Undeclared arguments default to int, although this is just better practice to declare everything. Bad function, yeah. Another appropriate symbol should be left of. Let's look here. I don't. Should we type void or should it be StackVM? Let's see what he's saying. 13 and 23. He doesn't like these. You know what? I think it's this. I think that's it. Okay, I don't have the answer to this, but we're very close to getting it working, and I think I will save this for a little bit later. Probably in the next few days, I'll figure this out tomorrow, and then I will I'll finish it. I'll finish it up on CPM, and we'll be able to run my virtual machine on CPM. That's it. Thanks for watching, and I'll see you in the next one.